In this class, now I am going to explain you one problem from complex numbers which was given in G Advanced 2019 paper 1. See that question. They gave one set in the set builder form and they are asking us to find minimum value of this set. See that set modulus of a plus b omega plus c omega square whole square such that a, b, c are non-zero integers and omega is complex cube root of unity. You know, we have three roots for cube roots of unity, 1 comma omega square. One is a real root and omega square are complex roots, and that too conjugate of omega is omega square and conjugate of omega square is omega. Now find the minimum value of this set. You know, students, see this expression. Mod of whole square is given. Magnitude of this complex number whole square is given. You know that mod z square can be written as mod z into mod z bar. Okay, students, because you know mod z and mod of conjugate of this complex number both are equal. Hence, in place of a mod z square, mod z bar, you can write this. If you replace this mod z bar by this, you will get mod z into mod z square. Am I right, students? You know, magnitude of a complex number is equal to magnitude of whose conjugate. So by this, you can write magnitude of a complex number whole square is equal to mod z into mod z bar. So by this can be written mod of a plus b omega plus c omega square into a plus b omega plus c omega square whole bar. You know, students, so mod of a plus b whole bar can be written as a bar plus b bar. A plus b, where a and b are complex numbers, a plus b whole bar can be written as a bar plus b bar. So apply that property to this, so that what do you get? A plus b omega plus c omega square into, what about this? A plus b omega bar plus c omega bar square. Okay, student, this you can write omega bar and this you can write c omega bar square. Just now I said to you, omega bar can be written as omega square and omega bar square can be written as omega, because both are conjugate to each other. The conjugate of this can be this and the conjugate of this can be this. If you take the conjugate of this, you will get omega square. If you take the conjugate of this omega square, you will get omega. Both are equal. Hence, in the next step, I am going to replace, this one I am writing as it is, a plus b omega plus c omega square, and replace omega bar by omega square. So, a plus omega square plus c omega. Now, multiply these two, because you know mod of z1 into z2 can be written as mod z1 into mod z2. So if you apply that, this can be written as mod of a plus b omega plus c omega square into a plus b omega square c omega. So okay, multiply both of them. So multiply, on multiplying, what do you get? In some brackets we may get like 1 plus omega square. So we use this relation while simplifying this. So finally you will get mod of a minus b whole square, see, here 1 by 2 of b minus c whole square, c minus a whole square. Like this you will get if you multiply these two. If you want, I can multiply. See here, a into a square, and a into this, ab omega square, and a into this, ac omega, and multiply b omega with these three, ab omega, and b omega with this, b omega cube, this with this, bc omega square. Now c omega square with this, now ac omega square, and multiply this with this, bc omega power 4, this with this, c omega cube. Now first write a square, next see, is there any b square? See here, when you multiply this with this, so where you have got here, this with this here, one b square will come. And here also this with this, while multiplying here you will get c square. So here b cube, omega cube, which becomes 1. Now here b square will be left. Here omega cube, which is equal to 1, c square will be left. Okay students, next where is where are AB? Here AB, here AB. Take AB common, inside omega plus omega square AB you will get. Now take BC common, here BC, where is another BC here? Omega power 4, which can be written as omega, because omega power 4 can be written as omega cube into omega. So as you know, omega cube is equal to 1 into omega. So that here, what do you write? Omega plus omega square, BC. So in the last one also, omega plus omega square, CA you will get. But you know this, 1 plus omega square, which is equal to 0. In place of this, transfer this one to the right side and substitute here and here as minus 1. So on substituting minus 1 in place of these three, so then it will become a square plus b square plus c square minus ab minus bc minus ca. Now in the next step, so what do you write? So see here what I am doing. Numerator and denominator I am writing with 2 by 2. Here a square plus b square plus c square minus ab minus bc minus ca. Now when you send 2 inside, then it will become 1 by 2 of 2a square plus 2b square plus 2c square minus 2ab minus 2bc minus 2ca. So now split this a square. 2a square as a square plus a square. Now this 2b square as b square plus b square. 2c square as c square plus c square. So here minus ab minus bc minus ca. So this total expression can be written like this, a minus b whole square, because here a square, see here we have sent 2 inside, now here 2 will come, 2ab 2bc 2ca. So here this a square, here minus 2ab 1b square can be written a minus b whole square. In the same manner here b square minus 2bc 1 c square can be written b minus c whole square, next c minus a whole square. See students, after this step, see in the problem itself they mentioned a, b, c are non-zero integers. To get the minimum value of this expression, you have to take a, b, c as 3 distinct consecutive integers, a1, b2, c3. In such case only this expression is minimum. The problem itself they mentioned a, b, c are distinct non-zero integers, which means that, so when do you get this is minimum? Whenever you take a is 1, b 2, c 3, or take any 3 consecutive integers, so that this will be minimum, because a minus b is greater than a modulus. If you want to take, you can, because whole square is there, always positive. This is always greater than or equal to 1. So these two are, this one b minus c greater than or equal to 1. What about last one? C minus a. So c minus a greater than or equal to 2 you will get. These are the minimum values. Actually, ABC you can assign any 3 distinct integers, but to get the minimum value, you better to assign ABC as consecutive integers. In such case only this expression will be minimum, because we have to determine the minimum value of that set. Okay, actually that was given in set builder form. We are converting into the roster form, but we don't want all. Just we want the minimum value of that entire set. Okay. So right, to get that minimum value, I am going to give this one as 1, this one as 1, this one as 2. See here. So if you write those things here, then it will become 1 by 2 of 1 plus 1 plus, if you write here 2, it is going to be 4. So 6 by 2, 3. So this is the required minimum value of that given set. Thank you.